Okay. In an article in the Journal of Small Business Management, successful startup businesses in the US and Korea were compared. One set of data compared educational level of people who manage successful startup companies in the US and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate for this analysis? Oh. Okay.
I think it would be the chi-squared because you have like your two, the US and Korea, and then you go by high school, undergrad degree, master's, and doctorate. So it's like more than just two other
More
ones.
than two, yeah. Okay, I can see that.
Would that be ANOVA then? Like
a what?
ANOVA?
No, I think it's the chi-squared one.
Oh.
I think Vincent sent us a thing saying how you could tell the difference between those two.
Yeah.
I'm going to open it real quick.
Okay.
Even though I think that's correct, but all right. I have it open just to look at for the next. All right, number 3. I'll just read these ones real fast. So human resources manager reported data from a recent involuntary reduction in force at her company. You're an attorney and want to determine if age discrimination was a factor. It's illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which test would be most appropriate?
I think it would be the test of 2 proportions.
Yeah. I was going to do that one or the independent or paired samples t-test.
Yeah, I think it would be the proportions because they give like 2 categories, the 40.
Yeah.
So they have like 2 groups, but then they took a section from each of those groups, like the amount that were terminated, so it would be a proportion.
Yeah. But isn't this one of the ones that you have to have like above 10?
Yeah, but they don't give us any information as to whether like the amount.
That's true.
So, so assuming that, you know, it followed like the rules for like every single one, I think that would still be the best option.
Okay. Okay, a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for the analysis? Okay. Is this a test of 1 proportion?
I think so.
Yeah. It kind of gives that in the, you're testing a proportion, so. Okay.
Which one would that be?
Or the test of 1 proportion.
Yes.
Okay. All right, ready for number 5, guys? Okay. A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate?
Okay.
Is that a paired samples t-test? Or is it in?
Yeah, I think it would be the paired samples t-test.
Yeah.
Because it's the same number for each of them, and it's the same group of students.
Mm-hmm. Oh my goodness.
It's getting intense. Now they're asking about intervals.
I know, right? Ugh.
Okay, so question 6. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same type of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for this study?
Paired samples T confidence?
I think it might be independent samples.
We've had a question like this before.
Oh, sorry, you were right.
Oh, okay.
Where it says that both appraisers had recently evaluated, so it was like the same 6 properties.
Okay.
So yeah, it would be the paired sample.
Oh my goodness. What are you doing? Here, my puppy wants to say hi. Hold on. Ah! Okay, there you go. Look. You see the people? Yeah. You're crazy. All right, get
So
down.
cute.
Get down. She's so needy. My goodness. Whoa. All right, it's homework time. You go lay down. Go lay down. Go lay down. Okay, sorry. All right.
Question 7.
Yes.
In a Wall Street Journal article on satisfaction with career path, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decided to contribute a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
Good question.
Independent samples T confidence interval. Wait.
Yeah, I think it would be the independent samples.
Yeah. Because you have psychology majors and accounting major. Wait. Psychology and accounting. So
Yeah.
2 separate things, but separate but the same. Oh.
Yeah.
Okay. All right, number 8. Oreo cookies. Double stuffed Oreos are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. Oh, you take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for the study?
Would it be the one sample t-test? Because it's just the one thing that we're trying to find the true mean for.
Mm-hmm. So the one sample T confidence interval, the second choice?
I think so.
Yeah.
All right. Excuse me.
Question 9. Which of the following best defines the notion of the significant level of a hypothesis test?
Okay.
Would it be the probability of rejecting the null hypothesis, whether it's true or not, for the level of significance for a hypothesis test?
Okay. Yeah, that one or the, yeah.
I think it's that one because the other one is the p-value.
Mhm.
Oh, which is the next question.
That's the answer?
Yeah. Yeah, because it says for question 10, which of the following best defines the notion of the p-value of a hypothesis test? And it would be the third one for question 10, the probability of
Nice.
observing sample
Yeah.
statistic.
Good job.
Yep.
All right. Ooh, number 11 is so hard.
I think it's the second one.
Is Vincent still with us? Yep,
Yes.
there he is. Okay. All right. Number 12.
So number 11 would be the second one. 95% confident.
So what did you say, 0.95 or 0.3?
So 11, do you guys have
Oh, yeah.
like
Oh, sorry.
number 2?
Yeah.
Yes. Excuse me.
Okay, so moving on to question 12. What is the mean of the distribution of the sample proportions? Let's see. This one I don't actually know how to.
Yeah.
I don't remember. Let's see. Okay.
I'm going to have to pull the book up now.
Yeah.
I wish there was a way to search the whole textbook.
Yeah, that'd be nice.
Okay, mean of the distribution.
there is a way to search the whole textbook.
Oh, okay. How?
Okay, so you go to the main page and you just use the search bar there. And it'll go through
Oh,
the whole textbook.
awesome.
Wow.
Good to know. All right,
Yeah.
so we are searching for mean of the distribution.
Of sample proportions.
Okay. Lesson 16?
Yep.
Yep. NP, no, that's large enough. Sample size, mean of P equals P. So is it 0.3?
I think so.
0.30, I mean? Yeah.
Yeah.
Okay.
We get 2 tries, so.
I know. Okay, good deal.
I thought it was supposed to be the p hat. Is it the same?
Well, P hat and P can be the same thing sometimes,
Okay.
Yeah.
right?
And the
Am I
mean of
understand?
p hat is equal to p.
Yeah.
So.
Okay. Number 13. What is the standard deviation of the distribution of the sample proportions? Okay. It's the P times the square root of P times 1 minus P divided by N. Does that sound correct?
Yep.
Wait. Sorry, that's the standard deviation.
Yeah, I think we are finding the standard deviation. Is N 100?
Uh-huh.
I got an answer.
Me too.
I am a pokey person, so I don't have an answer yet. I'm sorry.
No worries.
But was that correct? You used that the square root of P times 1 minus P divided by N?
Yeah.
Okay. All right. Just put in my calculator and I am done. Okay. I have an answer.
Okay. What'd you get?
I have 0. I don't think that's right. Looking at the choices here.
Yeah. I got
Try that again.
0.46.
Yeah, let me just.
I have 0.046.
Or yeah, 0.046.
Okay, just. I hate my calculator. Okay, square root is open. 0.3 times 1. Okay, 0.046.
Yep.
That's what I got.
Okay, good deal. What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
Okay, so this is where we just find the z-score and then plug it into the probability applet.
Okay.
So do we use z-score equals to value minus mean divided by the standard deviation?
Yeah.
What is the value?
The value for this one would be the 0.25.
Oh, that makes sense. Okay.
They have this in lesson 16 also, the how to do
Yeah.
these ones.
Oh, goodness. This is so much math.
Yeah.
So p hat is going to be 0.3. No. It's 0.3.
I think I found the z-score. And I have an answer.
Me too.
Okay. So after you put it in the app, then you put it in the other problem with the p hat minus p divided by the square root of p times 1 minus p divided by n.
Yeah.
Wait.
Or so you do the p hat, which would in this case would be the 0.25 minus p, which is 0.3, and then you divide that by what we got for the standard deviation.
Oh yeah, which is the 0.046. Okay. Okay. All right. So I have that.
Okay. Okay. So do you guys all have an answer for question 14?
Yes.
Yes.
Okay. What'd you guys get?
I have 0.046. Oh, sorry. No. The area I have 0.1374.
That's what I have. 0.138, mine rounded up.
Yeah.
138?
Yeah.
I have 137.
138.
What is your C-score?
My Z-score was negative 1.09108.
So my C-score is negative 1.092.
Okay. For when I divided it by the standard deviation, I did it again instead of using the number that we already rounded up, which is probably why they're different.
So what did you guys get for the Z-score?
Negative 1.091
Okay.
is what I got, and Vincent got 1.092.
Okay. Okay, so it's 0.138.
Mm-hmm.
Okay.
But like when I put it to like the C-score, if I put like 1.0918, it would just run it up to 1.092.
Okay. Are we on number 14 now?
Yeah.
All right.
No, that was question 14. Finding the 0138.
Oh, sorry. 15. It didn't save it. Okay, now it saved it. It's slow. All right, 15.
Yeah.
Sorry. Okay. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experiment, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the proportion of people who experience dizziness but do not take Acupril.
Okay.
Create a confidence level. Woohoo.
We're just finding the margin of error. Oh, by the way, do you guys want like the notes for exam 3?
Sure.
They have all the formulas.
Oh, awesome. Okay, so this one we would use the Excel doc, correct, for the two sample Z test for proportions?
I believe so.
Okay. So P1. Oh gosh. All right. So it's 579 and wait. $61 and then 1563. No, that's the whole sample.
What?
It's 561 and 579 people in the first group. And then there's so much information. Okay.
Yeah.
And 95% confidence level correct. Yep. Okay, I have 16 and 17, I think. And it won't take me that long to get 15.
Oh, okay.
Okay. Okay, do you guys have 15?
Not quite yet.
Okay. All right. I need to go get my cat from outside, so I'll be right back.
Okay. Let's take a minute. Finish this real quick.
Okay, sorry.
No worries.
So I don't know how to do it. Like for the margin of error, how do you guys do it?
That's where you add the upper and lower bound together and divide by 2.
Or you find the difference between them.
Yeah.
And then divide that number by 2.
Yeah, sorry. That's the most important part.
And how did you find a lower bound and upper bound?
You put it in the Excel spreadsheet.
The quantitative?
Categorical data analysis hat.
Oh, the new one. Oh,
Uh-huh.
wow. Okay. And use the 2 proportions, right?
Uh-huh.
Okay. I don't understand.
You know what you want?
So which one is the X1?
So X1 is going to be, or P1, is the true proportion of people who experience dizziness while taking the medicine. And then the second number is the people who have dizziness, but they don't take the medicine at all.
So X1 will be 579 then?
X. No. I'm doing homework here.
What do you have for X1?
What's that?
Huh?
What do you have for X1?
I have 61.
That's what I have too.
Yep.
And N1 is 1563 then?
Yes.
So in the paragraph, I don't understand it. It said like 579 subject in the control group.
So the 579 are the people who received the placebo.
Yes. So that proportion, the 15 out of 579, that would be P2.
Oh. Man, I don't understand the paragraph.
It's got a lot of numbers in it, so it is kind of confusing. Come on, lay down. Did you get him in there? Did you get him, Vincent?
Yes. And what type of test do you have? Is it not equal?
Yeah.
Yeah. Okay, so what do you have for the, do you have the margin of error yet?
I have. So the upper bound, the lower bound I have negative 0.003.
Uh-huh.
And upper bound I have 0.029.
That's what I have. Ashley, is that what you have?
Mm-hmm.
The margin of error I have 0.016. Is that what you have?
0.016? Yes. Ashley?
Mm-hmm.
Okay. All right, number 18.
I think it's the first one.
I agree. That's what I got
Depression. It's a second.
Okay.
Oh, okay.
Do you agree that it's the first one, Vincent?
Yes.
Okay. All right, number 19. The value of your test statistic is I have 1.458.
That's what I have too.
The p-value.
I have 0.145.
I have.
That's what I have. Yep.
All right. All right. Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness? All right. The P is low. Reject the null. We're not going to reject the null because the P is high.
I think it's the last one. The no, because I failed to reject null hypothesis. Yeah.
Tough to think about it in that way, like no or yes.
Yeah.
Okay. 22. You like the lesson we just did last week?
Yeah, the Kai or Chi,
Kai?
or however you want to pronounce
Chi
it.
or Kai? Yeah.
Whatever you feel.
Can we
So
call?
weird.
Yeah.
No, I don't think you. I don't know. Can you?
No, I don't think we can.
I think it's easier just to type them in.
So on these, when it has like the level of significance, so on the other pages, the other Excel docs, you can change the level of significance. How do you change the level of significance on this one? Or does it really matter?
I think, well, pretty much so for everyone like this, we've gotten 0.5. So I think
Okay.
maybe it's just always going to be 0.5 for this class. I hope.
Okay.
Since
Yeah,
there
because
is
the
no way
blue,
to change it.
yeah, because the blue area is the only place you can put anything, so that makes sense.
But yeah.
I was just double checking because they kept saying that in the book, and I'm like, well, there's nowhere to change that. Why does it keep saying it?
Yeah.
That was weird. Okay. All right. Do you guys have an input?
Yep.
All right. What'd you guys get for 22, the test statistic?
I have 6.579.
That's what I have too.
That's what I have.
I like
I like
how
these.
I
Yeah.
like how it said calculate the test statistic, but actually we didn't even calculate that.
Yep. All right. And for the p-value, did you guys get 0.087?
Mm-hmm. Which means for question 24, it would be the fourth one down.
Yeah,
No,
that's what I put too.
because it's greater than 0.5, yeah.
All right. So this one, it'll be one of the last two choices for number 25. It's probably the last one. Let me double
Yeah.
check. Yeah, not independent. It's the last one. All right. Recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of those outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period.
Okay.
Based on the results of the sample, create a 95% confidence interval of P. Input the lower and upper bounds below, rounded to 3 decimal places. All right. So this goes back to lesson 17, I think.
Yeah, because this would be the one proportion.
Yeah. X divided by N. Okay, I think I have the answer.
For 26?
Yeah. Oh, wait. Yes, the spreadsheet makes sense now. That's terrible. Okay, yeah, I think I have 26 and 27.
Okay, me too.
How did you find it?
I'm going to use the Excel doc.
That's what I did.
So what do you do for X1?
What was that?
Do we use one proportion?
Yes. Yes, it's a 1 proportion. Oops, sorry, guys. Sorry, lay down. Get down.
And you gotta make sure when you're doing it that you change the null hypothesis too. So it's the 0.2.
So I remember doing the homework on some of these, and I'm like, well, what are they talking about with the 20%? Where did that number come from? I just realized that's what it was in the null hypothesis.
Yeah.
And then did you put greater than, since we're trying to figure out? Wait, hold on.
The only one that really makes a difference on is the p-value, so it doesn't, for finding the confidence interval,
Yeah, it doesn't
it
matter.
doesn't really make a difference.
Yeah.
So what do you have for X? I have 200 for N, but I don't know what to put for X.
So it says,
So is it
yes.
200 times 20%?
No, so 200 is the total, and look at the second sentence. 100 investment managers that had graduated were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average.
Oh, so 50.
Yeah. Excuse me. Your confidence level.
95.
Okay, and then did you change your null hypothesis?
2.2.
Uh-huh.
Is it
All right, and then what do you have for the
not equal?
Huh? It doesn't matter on this one right now.
Oh.
Because we're just trying to find the lower and upper level of the confidence level.
Yeah, and it won't affect it. The only thing that affects is the p-value.
So I have 0.190.
Uh-huh.
And 0.310.
Yeah. Yes. All right, and then suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95% confidence? Use a prior estimate of p equals 0.2. This will go. Okay, so this is where we use the z divided by m squared times p times 1 minus p.
So we use the margin of error, like formula. So do we need to find a C-score first?
Well, not really, because that's like the 1.96 because of the 95% confidence interval. But we do have to find M first before we...
Okay.
Yeah, I think I got an answer.
Ah. Let's see. Okay, I think I have the wrong answer. Having my calculator wrong. All right, do you guys have something?
Almost. Okay, this one's got me totally confused. I have no idea.
Yeah, me neither. Because I got 170. Pretty sure that's not what it is based on the sample choices on the exam prep, like the paper. So I don't know what the heck I did. And then, okay, so I get confused sometimes because a lot of the time we're using 1.96, but that's for 99%, right?
95.
Yeah, 95 is 1.96.
Okay, hold on. All right, let me try this again. So 6 divided by 0.06. Why did I use 0.06?
So, are you guys using c-score times the square root of p times 1 minus p divided by n?
That's what
Say it
we
one more
do.
time. Z.
I'm sorry?
Yeah, sorry. Go ahead, Ashley.
Oh, I was just saying that there's like a handful of formulas there, and most of them would work. So.
Okay, so
That's what
I was looking in the book, and it says if we have a point estimator, we can plug this value into the equation above to compute the sample size required to obtain our desired margin of error. Oh. So I wasn't using that sample that you said, Vincent. I was using the n equals z divided by m squared times p times 1 minus p.
That's what I did. And then I got like 15 point something, but we'd round up to the next whole number, so we'd get 16.
Sorry, what did you get cut out?
Oh, I said I got 15.36 by doing that formula. The n is equal
Okay,
to.
so maybe the answer is. All right, what numbers did you put in there?
So I had 1.96 divided by 0.2, and then square that.
Okay.
And then it's 0.2 times 1 minus 0.2. It's kind of frustrating that, or like it's confusing that the confidence interval is the same as, or the margin of error is the same as P star. So.
Right. And see, I got 0.06, so I'm going to check my math. Because you did 0.31 minus 0.19 gets 0.12 divided by 2. Yeah, so I got 0.06 for the margin of error. But I guess that doesn't matter, right?
Well, no, it gives us the margin of error.
Oh, the 2%. Oh, okay.
Yeah.
All right.
Yeah.
All right, so I did mine the same way. The only difference I had is I used that 0.06. So I did the 1.96 divided by 0.06.
Gotcha.
I got 15.36 also. So the only choice in here, like when you're looking at the exam preparation on the paper, one of the choices is 16. So.
That seems right to me, so.
Yeah.
We'll just go with it.
Okay.
Yeah. Oh, wow, it's already 8 o'clock. I'm probably going to have to go in a few minutes.
Okay.
So just go through and get to what we can real quick.
Where do you see like the exam choices, like the answer choices?
They're on this the paper, the preparation assignment. So, okay. Suppose you wish to see if there's evidence that graduates in one of the top 10 perform better than the investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. So. Which of the following pairs of hypotheses is most appropriate? The third choice?
think so.
Okay. Oh, wow.
Yeah.
Oh, do you think that one is or not?
No, it is. I just read it wrong.
Okay.
It said, or like when it's talking about one of them is better, that would mean, would that be? Yeah.
Yeah.
That'd be just a difference.
And then number 30. That one's easy.
Is it the first one?
Yes. That was on number 30?
Mm-hmm.
Yeah. And then the test statistic, did you guys get 1.768?
Yep.
All right.
Okay.
Right.
And then what'd you guys get for the p-value?
0.077.
Yep.
Okay. And then P is low, reject the no. No, I failed to reject HO. My goodness. Excuse me.
Okay. Sorry guys, I've gotta go.
Oh,
So
it's okay.
good luck with the test and enjoy
All right.
Thanksgiving.
You too. See you next week.
Yep. Bye.
Bye.
Bye. Vincent, what number are you on?
I am at 36.
Oh, okay. What'd you get for 34?
Oh,
Oh, wait, hold on.
I'm sorry. I'm at 31, 33.
33. Okay. 33. I picked the last choice. So,
Yes.
oh, goodness. Hi, B. All right. So, are you on number 34 now?
Yes.
Excuse me.
Oh, we still got lots of questions.
Yeah, we're good though.
I still have a test to take tonight.
Oh my goodness.
Oh, I want to kill myself.
We can do this. We got this. Well, let's look at what else is left on here. Oh my goodness. Where are people? Okay, so I think 34 is like some of the old problems. What do you think?
So, have you opened the Excel sheet yet?
Yes, the blue scores.
Yeah.
Yeah, it's just a sheet, or like it's just a listing of a whole bunch of scores and data, like one column of them.
Yeah. So is it supposed to be one proportion then?
I don't think this is a proportion one. I think this is one of the old ones, like one sample t-test or something.
Really?
Not that, yeah, I think it's one of the older ones.
So this is not categorical?
I don't know. Okay. Computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. The quality of the translation can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translations produced by Pharo are. The IBM T.J. Watson Research Center developed methods to measure the quality of a translation from one language to another. One of these is the Bilingual Evaluation Understudy, or BLEU. A BLEU score is a number ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. BLEU helps companies who develop translation software to monitor the effect of daily changes to their systems in order to weed out bad ideas from good ideas. Okay. To compare Pharo's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharo to translate each of these to English. The BLEU score was calculated for each of the 100 blocks. These scores are recorded in the data file. He wants to use this data to see his mean BLEU score differs from the mean BLEU score of another leading translation software, which has a population mean score of 0.295. Okay. Assuming the requirements are satisfied, construct a 95% confidence interval for Pharo's true mean. So is this the one sample t-test for means?
I think so.
Okay. So we put all the information in there, copied and pasted it, right?
Mhm.
And then it's a 95% confidence interval, correct?
Mhm.
And input the lower bound, okay?
The lower bound.
I got 0.282,
Yeah.
and then upper bound I got 0.293.
Yeah.
Okay. All right, degrees of freedom, that's easy.
I have
Which is
99.
the, I got 99 also. And then the test statistic, I got 109.091.
Oh,
Is that what you got?
no. But mine is like a crazy number. I don't know why.
For the T, not
Yeah.
the p-value, the test statistic, what did you get?
I have negative 3,683.938.
What?
I don't know where does that come from.
Did you yeah, the confidence level is 0.95?
Yeah.
What the heck?
What do you have for the null hypothesis?
0.
Oh, I have 10.
Maybe that'll make a difference.
So how do we know what is the null hypothesis?
Um, well, it's usually 0, I guess.
But why is mine 10? Oh well. Okay, now I have 109.091.
That's what I have.
The
I
p-value?
have 5.881.
Do you have greater or less
Actually, hold on. I think we have those wrong. Because go back up to above question 36, the information.
than?
So it says mu equals 0.295. So I think actually where that null hypothesis where you had 10 in there, I think we're supposed to put 0.295 right there.
Oh,
I mean, if you don't agree, that's fine, but
I agree.
see down there where it says one sample t-test, null hypothesis, mu equals 0.295.
Yeah.
Dang, if I've been getting problems wrong all along because of this, I'm going to be so mad.
Yeah.
So that makes our degrees of freedom is still correct, but our test statistic is negative 2.803.
Yep.
Okay.
And the p-value will be 0, 0.006.
Yes.
Whew, okay.
Man,
You saved a
sorry
lot.
about that. We would have gotten that wrong. Ugh. All right. Based on the results of this test, what should you conclude? The p is low, so we reject the null. But this is where I get confused when I don't have like we reject the null hypothesis. So does that mean we have insufficient evidence or sufficient?
We have insufficient.
Okay.
So it will be the second one.
Okay. I was just going to say that. Whew, okay. So if the p is low, we reject the null, and then it's insufficient evidence?
Yeah.
Okay. All right. Number 40, and we have to open up another Excel doc. A study was done to test the notion that people are taller than when they first wake up in the morning than in the evening, not right before they go to bed. Oh, this question is familiar. To test this theory, the heights of children in a boarding school in India were measured. Values are recorded for each child in the morning and again in the evening. If you want to determine if the children are taller in the morning than in the evening, define the differences as AM height minus PM height. Okay, so this one is going to be the paired sample t-test or two sample?
I think
I
pair.
think it's the paired sample. Construct a 95% confidence interval. Conduct a hypothesis test at a level of significance of 0.05 to determine if the children are taller in the morning than in the evening. Okay, so AM height, PM height. Okay. All right. Lower bound.
What do you put for the null hypothesis?
Just 0 because there's nothing in here. Well, let me look.
What about the 0.05?
Oh, I don't have anything for I have the confidence level as 0.95.
Oh, okay.
Yeah. So we know it's a 0 for the null hypothesis.
Okay.
Okay. So the lower bound, whoops,
I have 8.728.
that's what I have. And for the upper bound, I have 10.455.
Yep.
Okay, the test statistic,
22.6446.
yes, 22.446. Degrees of freedom is 40. Input the p-value. Okay, we have to figure out what is the construct a 95. All right, they're saying to test this theory. So they're wanting to know if kids are taller in the morning or in the evening. So it'd be not equal, correct?
Oh, great. They want to see if the morning will be taller.
Right.
So is it
So greater than.
greater than?
So 1.397.
Yeah.
I mean, it's either that or it is 2.794. So I guess we'll see. All right. Based on the results, is there enough evidence to suggest that the children are taller in the morning? Okay, the P is low. Reject the null. So it's no, because we fail. It's the first one, right?
Yeah.
Okay. All right, Vincent. Moment of truth.
Oh well.
I think we did okay. Crossing my fingers. We did good. Dang.
Wow.
Did you get 34 out of 43?
I got 33. Almost 43.
All right, so going back to number 2, did you get that one correct?
Yes.
Did you get number 3 correct?
Yes.
Number 4?
Yep.
Number 5?
Yep.
Number 6? Ooh,
Yep.
did you get number 7 right?
Nope.
Me neither. Dadgum. This is so frustrating. I bet number 9 was the probability of the type 1 error. Let's see what else I got wrong. Right. Right. Okay, number 28 was wrong for me. So is 29.
Yep.
And number 32.
Want me to send him back here?
Who is here?
I don't remember his name. King?
Ask him to come in. I have to go soon.
Okay, Vincent, I can't look at that thing you sent me.
No?
No, because remember, like you have to have permission to look at that Google Drive.
Let me give you the permission real quick.
Okay.
I will accept you.
Okay.
I'm almost done. Just give me. Let's see. Yeah, that thing's just good stuff. So.
Okay, good.
Okay. Man, my computer is so slow. Okay, I'll just share with you.
Okay, cool. Oh yeah, I got an email from you, so thank you.
Yeah, so there's all the formulas and stuff.
Awesome.
Yeah.
Yay. Okay, cool. All
Sorry
right.
to go now.
No, that's okay.
Okay.
I think I'm gonna table this and just work on it tomorrow because it's not due till tomorrow anyway. So
Yeah.
um,
If you want to, we can like meet again tomorrow, like to go through it. If you
I'm
want.
okay with that. Like I won't start it. I'll wait. I can do that.
Okay. Yeah.
All right. What time do you want to meet? I can meet anytime after 5 my time. So
Fine. I don't know. I will email you after I get off work.
okay, that sounds good.
Okay.
All
Awesome.
right. See you tomorrow.
Good night.
Okay. Bye.